Okay, today you are going to study for tomorrow's quiz. You see in pink at the top, those are the pages you should focus on for studying. And let's take a look at page 18 before you get into the quiz review. On page 18, you are asked to state the period, the amplitude, and the midline for each graph. When I look at number 1, it's really giving me sine vibes. I notice here at 0, 0, that's the first thing I always want to do. Oh, it looks like a sine graph, starts in the middle and it's going up. Remember, a sine starts in the middle and goes up, center, top, center, bottom, center. And just to check, I have 1, 2, 3, 4. And then double check it, 1, 2, 3, 4. Yep, so my amplitude for this graph is 4. My midline for this graph, I can see it's at y equals -2, or 3, -3, and it ends its period at pi. Okay, now number 2, I'm going to do it slightly differently. I see that it's a cosine graph. I see it's got a top at 1, and I see it's got a bottom at -3. So for my amplitude, actually let's do the period or the midline first. For the midline, I can do the max minus the min divided by 2. So 1 minus -3 divided by 2, that's going to give me, no, it should be a plus, my bad. I'll do it the other way. Plus 1 plus -3 divided by 2 would be -2 divided by 2 is y equals -1, and that is indeed the middle. And then the amplitude, we're going to do the max minus the min divided by 2. 1 minus -3 divided by 2 is -4 divided by 2, and we have an amplitude of 2. So I'll mark. Let's clean this up a little bit. The recording tools are covering the undo, and I missed that. So I have an amplitude of 2. Okay. The period, I see it goes top, center, bottom, center, top, back up here to 4 pi. So the period is 4 pi. First set of problems is to do some conversions between radians and degrees. I'm going to do it, remember we have 2 different ways to do this. We know that degrees over radians equals 180 over pi, and we can just solve that proportion. Or to get from radians to degrees, you can multiply pi over 180. It's really your preference. I'll do the proportions first. So I have 50 over x equals pi over 180. Whoops, whoa, other way around. Oh, I can't, like, I'll get an eraser. So now when I cross multiply, I get 50 pi equals 180x. I'm going to divide both sides by 180. The zeros cancel. They both divide by 10. 5 and 15 don't have any common factors, so our answer is 5 pi over 18. I'm going to do the next one simply by multiplying by pi over 180. So I've got 135 times pi over 180. Now, nothing's divisible by 10, so that's annoying, but they are both divisible by 5. So if I divide this by 5, I will get 18 times 2 is 36. 100 divided by 5 is 20. 35 divided by 5 is 7, so I get 27 pi over 36. Both of those numbers are divisible by 3, and that gives me 9 pi over 12, and I can divide that by 3 again, and I get 3 pi over 4. Okay, I'm going to do the first one with proportions for radians to degrees, and then the second one I'm just going to multiply by 180 over pi. You can do whatever you like as long as I see a little bit of work. So I've got radians over degrees equals 180 over pi. That gives me x pi equals 7 pi over 6 times 180. The pi's will cancel. And now 180 is divisible by 6 because 18 is divisible by 6 3 times. So this becomes a 30. And then 7 times 30 becomes 210 degrees. Here we're just going to do pi over 2 times 180 over pi. The pi's will cancel. And then 180 divided by 2 is 90. I'm going to do this one with proportions. Degrees over radians equals 180 over pi. I'm going to cross multiply. I'm going to kill the zeros, divide by 10. And now I have, whoops, I forgot the x. Here I'm going to divide both sides by 18. 30 and 18 are both divisible by 3. I'm going to start with that. That gives me 10 pi over 6. Those are both divisible by 2. So my final answer is 5 pi over 3. 270, I'm just going to multiply by pi over 180. The zeros cancel. 27 and 18 are both divisible by 9. That's kind of the easiest thing to do. It kind of jumps out at me. If I divide both of them by 9, I get 3 pi over 2. Okay, so now for the last one, I'm just going to multiply by 180 over pi. Oops, kind of low. Pi's cancel. 180 is divisible by 4. If I divide it by 2, that would give me 90. And then 90 divided by 2 again gives me 45. And then 5 times 45 is going to be 225. Okay. Number 2 says angle theta is in standard position with a terminal ray in quadrant 3, and the cosine is negative 1/5. Use the Pythagorean identity to find the value of sine. So because I'm in quadrant 3, I want to remember that this sine value is going to be a negative value because the y will be negative in quadrant 3. So here we go. Our Pythagorean identity is sine squared theta plus cosine squared theta equals 1. You could always switch that around if you like and make it cosine squared theta plus sine squared theta equals 1. It really doesn't matter. So I'm going to go sine squared theta plus negative 1/5 squared equals 1. I've got sine squared theta plus 1 over 25. I'm immediately going to write this as 25 over 25 because that way when I subtract the 1 over 25, it's nice. I have common denominators. So this leaves me with sine squared theta equals 24 over 25. I'm going to take the square root of both sides. Now I only want the negative one because I'm in the third quadrant, so I know the sine of theta is negative root 24 over 5, which is a perfectly acceptable answer. Or if you like to reduce the radical, you can make that 4 or 2. The square root of 4 is 2, so this can become 2 root 6 over 5. Okay, now we are in quadrant 4 and we are looking for cosine. Now cosine is positive. We have a positive x in quadrant 4, so we'll keep that in mind. So here we go. Sine, man, I missed the undo. Sine squared plus cosine squared equals 1. 4 over 9 plus cosine squared. I'm going to write this as 9 over 9, so that way when I subtract, I get 5/9. I'm going to take the square root of both sides. And I don't want the minus here because I'm in the fourth quadrant. So it's just going to be the square root of 5/3. All right, so now we are told 0 to pi, which could be quadrants 1 or quadrant 2. And we are looking for the value of sine. Now, the good news is sine is positive in both of those quadrants because y is positive. So sine squared theta plus cosine squared theta equals 1. This just drops out. If I were to take the square root of this, I would get sine squared theta equals plus or minus 1, but I really only want the positive 1. I don't want the negative 1 because we are in quadrants 1 and 2. All right. The back, we are looking for the period, the amplitude, and the midline. So I'm going to make some notes. I see a top point, a bottom point, and a top point, like it's a cosine graph. So this is a really nice looking cosine graph. And I immediately can see that the period here is 4 pi. Because it completes one cosine cycle in 4 pi. Just as a reminder, one regular sine period is center, top, center, bottom, center, and then it graphs like that. And then one period of cosine is top, center, bottom, center, top, and it graphs like that. It's almost like the top, like this piece of the sine, got cut off and put here. All right, so I know the period of that graph is 4 pi. I see it has a maximum at 3. It has a minimum at -3, which means that the midline must be at y equals 0, and the amplitude is 3. Okay. Letter B, this is starting to look like a sine graph. Starts in the middle and goes up, so I'm going to mark my 5 points. And I see that we end here at pi. So period is pi. These center lines, make sure you check your scale, are at y equals 3. And the amplitude is only 1, even though there's 2 squares. Okay, and then the 2 down here. Whoop, sorry. Right here, this looks like a sine graph. Center, top, center, bottom, center. This looks like 1, so the midline is y equals 1. This goes up to 5, so 1, 2, 3, 4. And the period to complete one cycle is 2 pi. All right, last we have a cosine graph here. It starts here at the top at -4, goes down to 0, so this must be my midline. I see it finishes the cosine graph here, so that means the period is 2 pi over 3. And what are we missing? The amplitude from 2 to 4. The amplitude is 2. Remember, this is our amplitude. All right. I hope that was good.